All right, in this video, we're going to be going over the Chapter 9 study guide, so make sure that you have it out in case you need to make any corrections on the study guide that you have, or you need to start filling your study guide in if you didn't start on it the other day. So we're just going to dive right in. We're going to go through all of the different problems, and once you get all of the answers in, you'll be set for the test. So let's dive right in. All right, so the first 3 questions are asking you to determine whether the question is a statistical question. All right, so remember, when we said a statistical question is a question where you would expect different answers for. So number 1, how many years of experience do elementary school teachers have? Now, it could differ for every elementary school teacher. One teacher might have 2 years of experience, another teacher might have 6 years of experience. So we can say that this is a statistical question because years of experience could be different for everyone. So I'm going to say yes. Number 2, what is the favorite food of 6th grade students? Now, this isn't technically an answer we would expect a number for, a question we'd expect a number for an answer, but still, it does ask for different categories. Different 6th grade students may have different favorite foods, so since we'll get a different answer, this is also a statistical question. Number 3, the height of the Empire State Building is not a statistical question because that's the same answer for everything. So now, we have our statistical questions. But our next section asks to display the data in a dot plot. Identify any clusters, peaks, or gaps in the data. So remember, a dot plot, we use a number line first of all. So I'm going to start with number 4. All right, so we have a range of 0 to 6. So I'm going to make my number line and have 0 be here and 6 be here. And then we have 1, 2, 3, 4, 5. All right, so now we have numbers 1 through 6 here. All right, so the number of zeros that we have in our data is 5. So we're going to go with our dot plot 1, 2, 3, 4, 5. We have 5 zeros. And then ones, we have 3. So in my dot plot, I'm going to put 3 where my 1 is. 3 where my 1 is. All right, so now 2, I have 4. Pretty straightforward on your dot plot. 1, 2, no 3s, no 4s, but we have 2 5s. We have 2 5s here, so there we have that filled out, and then 1 6. It also asks us to identify any clusters, peaks, or gaps in the data. Now remember what a cluster is. A cluster is where a bunch of different values are just bunched together. That's what a cluster is. So this will be our cluster. I'm going to box it. That's our cluster. Our peak in our data, well, is at 0 because 0 has the most data points, and we have 5 data points for 0. Our gap in our data is evidently between 3 and 4 because our gap represents where no values are. So that's our gap. So this is our cluster, this is our peak, this is our gap. Now let's do it for years. All right, so we have years from 2010 to 2015. So I'm going to do 2010. I'm going to start off my line here with 2010. And it's going to go all the way to 2015. 2015. All right. And we have 4 in between. All right, so 2010, we have 2 2010s. So I'm going to put that in my dot plot. 2011, we have 1, 2, 3, 4. So 4. 2012, we have 1. And we have 1 for 2013. 2 for 2014. And then 2 for 2015. So now we have to identify clusters, peaks, or gaps in our data. So we know that this right here is a cluster, and then 2011 is our peak. Are there any gaps? Doesn't look like there are any gaps in our data because every data point, every single year has at least 1 dot. So I don't think there's any gaps in our data here. All right, so now we have to find the mean, the median, and the modes of the data. So number 6, we're looking for the mean, first of all, and what is our mean for that? So we're going to calculate our mean. And remember, when you calculate mean, It's just adding all of the numbers together. So let's add all the numbers together. 4 plus 6 plus 5 plus 4 plus 5 plus 4 plus 8. All right, equals 40. And how many points are there? Data points? 1, 2, 3, 4, 5, 6, 7, 8. So we take the number of values that we have, divide it by this, and divide the sum of all the values by the amount of numbers that we have. So 40 divided by 8. And our mean equals 5. So that's our mean. All right, so now let's find our median. And to find our median, we got to sort these numbers from least to greatest. So we have 4, 4. We have 4 4s. And then we have 5, 5, 6, 8. All right, so now we can determine our median. Now remember, we have an even number here, so when we're finding the median, we've got to find the value that's in between the two middle numbers. Our two middle numbers are 4 and 5, so the median is going to be the number in between that, or 4.5. All right, now we have our mode of our data, which is the most common data point. Our mode equals 4. It's pretty straightforward. Same thing for this one. All right, so let's add our numbers together. 95 plus 90 plus 100 plus 90 plus 85 plus 95 plus 75 equals 630. And we have 7 data points. 630 divided by 7 is 90. So our mean of our data, 90. Our median will be determined by putting our numbers from least to greatest, so 90. Actually, 85 is our first value. That's smallest. Nope. 75. Wow. I'm not doing too well with this. All right, so 75, 85, 90. 90. Then we have 95, 95, and 100. Kind of looks like test scores with what we're comparing right now. All right, so we have our 7 numbers, and the median, since it's 7, we have one number that's in the middle of the two values, so we know that our median is 90. Median is 90. And our mode, we actually have 2 modes because 90 and 95 are the 2 most common. So our modes are 90 and 95. All right. So number 8 and 9 are pretty much the same thing. Find the mean, median, modes of the data. Choose the measure that best represents the data. All right, so when we're asking to choose the measure that best represents the data, that means it wants us to say, okay, what measure do we think best represents all of the different numbers in the set? So I'm going to find the mean, median, and modes of these, and then I will come back. All right, so I've put together the mean, median, and modes of the data. So we have, for this data, we have a mean, adding it all together, dividing it by the amount of numbers. We have a mean of 76, median, our middle value of 79, and mode, our most common value, well, we actually have no mode because all of the values are different in our data set. There's not one that's more common than any of the others. So no mode. All right. The measure that best represents our data, I would say, is 79 because 76 would fall right here in our data. 79 is right in the middle. So I think the median is the best representation of our data here. And on number 9, mean, median, and mode are calculated here on your right. So I'd say for this set of data, the best representation of our data is again also the median, because the median sits right in between all of our different data points. But also the mean could be a good representation because we have an outlier sitting here of 2. Our outlier of 2 could have a big alteration on our different data set. So the important thing is you're choosing the measure that best represents the data, but you have to justify why you say that. Why are you saying that this is the measure that best represents our data? All right, so number 10 I also did already because we've gone through mean, median, mode quite a bit. So our mean is 1.07, our median is 1, and our modes are 1 and 1.5. There's 2 modes because they're both the most common. All right, number 11, finding the range of the data. Remember, the range just shows us how much range there is in between the highest value and the smallest value. So the way we find that is we subtract the highest value from the smallest value. Our highest value is 91. Our smallest value is 13. So all we have to do is we just have to do 91 minus 13. And our range is 78. 78 is our range. All right, number 12, we're doing the same thing. We got to find our highest value. Our highest value here is 114. And our lowest value on here is 89. So we do 114 minus 89. 114 minus 89 is 25. So our range is 25. And remember, when finding the range, we're trying to figure out, okay, how spread out are our values? These values are very spread out because we have a larger range. These values are not as spread out because we have a smaller range. So this just helps you determine how much variation we have in our data. Same with these measurements, first quartile, third quartile, interquartile range. All right, so our median, we've got to identify all of our different stuff here. So let's list these from least to greatest. We have 0, 4, 6, 11, 18, 20, and 22. All right, so the median of this data, we have 7 values. Our median is 11. Median is 11. Median equals 11, so we know this is our median. And remember, the first quartile is the median of the lower half of our data. So our first quartile would be 4 because it's in the center of our lower half. So this is our first Q, I'm going to put, first Q. Now our third quartile is 20. And remember, median represents our second quartile. So now we just have to find the interquartile range. We have to take the third quartile and subtract the first quartile from it. So 20 minus 4 is 16. So our IQR, interquartile range, is 16. All right, let's do this one now. So here we have 16 is our lowest value here. Then we have 20 and 25. Oops, lost my lead there. 25. So 16, 20, and 25. Then our next highest number is 53. And our next is 65. And then we have 2 92s and a 70. All right, so we've sorted out the data from least to greatest. Now we can find our median, first, third quartile, interquartile range. So our median is actually going to be a number in between 53 and 65. So what's 65 minus 53, first of all? 65 minus 53 is 12, which means our median is going to be 6 higher than 53. So I think our median is 58. That's our median, 58. All right, so our first quartile is going to be in 20 and 25. So in between 20 and 25, we have 22.5. That's our value in between 20 and 25. So now our third quartile is going to be 92 because both of these two numbers are 92. So now we just have to do 92 minus 22.5, and that'll give us our answer of 69.5 for our interquartile range, just like we did on this side. All right, so now let's turn to the other side. We're diving into some other things now. We're diving into the mean absolute deviation, the MAD score. So I know you're probably mad about doing this, but the MAD score, so we're gonna start off, I already identified our mean for us. Adding all these together, dividing it by the amount of numbers gives us 5.625. So in order to find mean absolute deviation, our first step is to find the difference between all of these data values and our mean. So first off, we're going to start off with 10 minus 5.625. What does that give us? 4.375. So 4.375 is our first data point. Next up, we have 7 minus 5.625, and that gives us 1.375. Looks like we're gonna have a lot of 375s in this. All right, and then 5 minus, now we have a number less than the mean, so we're gonna start with the mean first. So we're gonna do 5.625 minus 2, that gives us 3.625. 3.625, I'm running out of room here. We're gonna do 5.625 minus 5. What does that give us? 5.625 minus 5 should just give us 0.625. Yep, 0.625. All right, next up we have 5.625 minus 3. That gives us 2.625. 8 minus 5.625 equals 2.375. And then we have 0. We have just 5.625 because we have 0. And then 10 minus 5.625, which is 4.375. All right, that's probably kind of hard to read, but these are our 8 values made into differences between their value and the mean. So now, in order to calculate the MAD score, we add all of them together. So this is going to take a minute because they're all decimals. So we are going to do 4.375 plus 1.375 plus 3.625, 3.625 plus 0.625. 2.625, 375 plus 5.625 plus 4. Don't forget your decimals, 4.375. It's a lot of numbers. All right, gives us a 25. And what's 25 divided by 8? 3.125. So our MAD score is 3.125. And it says to round to the nearest tenth, so it'll actually be 3.1. 3.1 is our answer. Now for number 16, do the same thing. Already calculated the mean for us, so now I just got to find the difference between the values and the mean. So we are going to start with 57 minus 56.375 is 0.625. And I will do these real quick and come back. All right, we have our 8 values here. This might be a little bit hard to read, but we got 8 different values here. We know our mean. We subtracted each of these numbers, or find the difference between each of these numbers from their mean, and determine these different scores. You should not have any negatives when finding the MAD score. So now all we have to do is add them together and divide them by the amount. So 0.625 plus 3.375 plus 4.375 plus 2.625 plus 4.625 plus 0.625 plus 1.375 plus 0.625. That was a mouthful. All right, so adding them all together, we get 18.25, and then let's divide it by the amount of numbers, 2.28125. Now we're rounding it to the nearest tenth, so that means our MAD score is actually 2.3. 2.3. All right, so now we're moving on to the word problems. The table shows the number of students in a homeroom of 32 who brought a lunch from home each day. Find the mean of the data. All right, pretty straightforward. We add these numbers together. Let's add them together. 18 plus 14 plus 20 plus 16 equals 68. And then we divide it by the amount of numbers, gives us 17. So our mean is 17 because we did 68 divided by 4. Because that's the amount we have. So that gives us 17 for our mean. All right, so that's our mean. And now it's asking, Friday is a class field trip and all 32 students bring their lunch. All of them bring their lunch. Nice. Will the mean for the whole week be greater than or less than the mean for Monday through Thursday? Explain, then find the new mean. All right, so if we have a higher value, if we have 32 for Friday, 32 for Friday as well, then that means that our mean is going to increase, right? Because if we have a higher data value, our mean is going to be a better representation of the average of our data if it increases with our 32. So now we have to find the new mean. So we know that these 4 equals 68. 68 plus 32 equals 100. So this gives us 100, adding all of these 5 together. So we have 100, and since we have a new data point, we divide by 5. Our next mean is going to be 25. See how much it increased? It increased by almost 10 when 32 came around. All right. The data are the number of minutes students spend studying for a test. 35, 32. So all these different numbers. Find the mean, median, mode, and range. So it's asking us for quite a bit here. All right. So the mean we calculate is 35 plus 32. It's the sum of all the numbers, remember, plus 38 plus 34 plus 36 plus 69 plus 32 plus 25 plus 41. And that gives us an answer of 343. And how many different data points are? 1, 2, 3, 4, 5, 6, 7, 8, 9. 343, then we have to divide it by 9. Divided by 9 gives us a mean of 38.1. 38.1. So our mean equals 38.1. All right, so now we have to find our median, mode, and range. I'm going to find range first because that one's pretty easy. Mean, median, mode, range. So let's see, our median, we'll find in just a second. Our mode, we just have to find our most common value. And our most common value, it seems to me, is 32. So our mode is 32. And our range is our highest value minus our lowest value. So our highest value is 69. And our lowest value is 25. 69 minus 25 gives us 44. All right, so we have our mode and our range. Remember, mode's the most common value, which is 32. Range is highest minus smallest number. Now, to find the median, we got to sort it together. Sort them all from least to greatest. So 25, 32, 32. We have two 32s there. 34, 35, 36, 38, 41, and 69. All right, so what's our median? We have 9 values. That means there's going to be 4 values on both sides. Our median's 35. So those are your 4 values. Now, which is the best represents the data? I think the best representation between mean, median, and mode appears to be the mean for me. Because if you look at the median is on the lower end, still somewhat on the lower end of the amount of time they studied. 38 shows how many astute includes how many astute studiers there are in the right end. You have someone who studied well over an hour for a test. It's a lot of work. All right, number 19. The table shows the 5 fastest and 5 slowest finishing times for a track race. Find the MAD of each data set, then compare their variations. All right, so each data set, we have the 5 fastest times, the 5 slowest times. So I'm going to calculate the mean of these real quick, and then I'm also going to calculate the differences between the numbers and the mean so that we can calculate these. All right, so I've calculated the mean for both different data sets and the differences between each number and their mean. So now in order to find the MAD score, remember, we add all of the differences between the number and its mean and the mean of the data set together. So I'm going to add all these together real quick. 1.6 plus 0.6 plus 0.4 plus 0.4 plus 1.4 gives us 4.4. So we have a total of 4.4, and then in order to find the MAD score, we divide our total of 4.4 by the number of data points there are. So 4.4 divided by 5 gives us a MAD score of 0.88, which means we have a very low amount of variation or deviation from the mean in this data set. All right, so now our MAD score for this one. Our mean of 66.6, we have our 5 different numbers. So 6.6 plus 5.6 plus 2.6 plus 3.4 plus 11.4? Is that what I wrote? Yeah, 11.4. 11.4. It gives us a total of 29.6, and in order to find the MAD score, we divide it by the amount. 29.6 divided by 5 gives us 5.92. So there's quite a bit more variation between this side and this side. All right, last one, number 20. The data are the number of CDs purchased by students last year. Find the measures of center and the measures of variation for the data. So for this data set, we're finding everything. So I'm going to list it off. First off, we have mean. We have mean, median, mode for our measures of center. Then we have range. And we have our MAD score. And I'm going to identify the first and third quartiles also on here because those are also part of our measures of variation. I'm also going to include interquartile range. We're finding everything for this one. So let's first start off by calculating our mean. Remember, Mean, we're adding all the different numbers together. So we're going to start off by calculating it. So plus 1 plus 6 plus 2 plus 8 plus 3 plus 5 plus 12 plus 7 plus 0 gives us 49. So the sum of all these is 49. And divide it by how much? We have 1, 2, 3, 4, 5, 7, 8, 9, 10. So we're dividing it by 10. Dividing it by 10, that was not what I meant to do. 49 divided by 10 gives us 4.9. So our mean is 4.9. Next is our median. We got to sort these from least to greatest. So 0, 1, 2. Our next number is 3. Then we have 5 and 5, 6, and then 7, then 8, then 12. All right, so we sort them from least to greatest. We have 10 values here. So our median is the number that's in between these two, since it's the number of values, and the number between 5 and 5 is, well, 5. So that makes it pretty straightforward. Our mode is also 5, because it's the most common value. So all of these are pretty much the same number, except the mean is just slightly lower than all the other numbers. So our range is highest minus smallest, which is 12. Piece of cake, 12 minus 0 is 12. And then our MAD score. So now I got to find the differences between all of these numbers and the mean. And the mean is 4.9. So we're going to have to calculate all of these. So 5 minus 4.9 is 0.1. 4.9 minus 1 is 3.9. And then 6 minus 4.9 gives us 1.1. 4.9 minus 2 is 2.9. 8 minus 4.9 gives us 3.1. And then we have 5 minus 4.9 again, which is 0.1. Oh, wait, no. We did 8 minus 4.9. Now I have to do 4.9 minus 3. 4.9 minus 3 is 1.9. All right, and then we have to do 5 minus 4.9, which is 0.1. Then I'm going to move down to here, since I'm running out of room. 12 minus 4.9 gives us 7.1. 7 minus 4.9 gives us 2.1. And then 4.9 minus 0 is just 4.9. All right, so we have all these together. Remember to find our MAD score. Now we have to calculate all of our different, or we have to add all these together and divide it by the amount of numbers there are. So let's add them all together. 0.1 plus 3.9 plus 1.1 plus 2.9 plus 3.1 plus 1.9 plus 0.1 plus 7.1 plus 2.1. You're probably sick of me saying numbers. Plus 4.9 equals 27.2. 27.2 divided by 10 gives us 2.72. So is the variation that high? It's not really terribly high, but it is there. Now our interquartile range. So we know our median is 5. And since we have 5 values on both sides, we can determine that, okay, our median here is whatever number's in the middle. So our first quartile is 2, and our second quartile is 7. So our interquartile range will be 7 minus 2, so it's going to be 5. And there we have computed all the measures of center and all the measures of variation for our data. We have our mean, median, mode, first quartile, third quartile, range, MAD score, and interquartile range. All right. A new student is added to the data set who purchased 17 CDs last year. Is 17 an outlier? How does adding this value to the data set affect the measures of center and variation? Well, we know the measures of center are going to increase. The measures of center will increase because it's a higher number. And the measures of variation are going to broaden. And what I mean by broaden is that they're going to become larger because there's even more variation in our data because that's a high number. So that's why 17 will increase our measures of center and broaden our measures of variation. All right, so to find out if 17 is an outlier, we would do quartile 3 plus 1.5 times our interquartile range. So what's our third quartile? Our third quartile is 7, so let's do 7 plus 1.5 times our interquartile range, which is 5. So 7 plus 1.5 times 5 gives us 14.5. Any number higher or at or higher than 14.5 would be considered an outlier. So is 17 an outlier? Yes, 17 is an outlier. All right, so that's your entire study guide. I know we went through that kind of fast, but there was a lot to cover and not much time to do it. So all this is covered. Make sure you study all of these different processes that we talked about in preparation for your test tomorrow.